Good morning, students. So, whether my screen is visible, am I audible?
Yes, sir.
Right, fine. So, good morning. Welcome to the module 24 in the IC engine subjects in the unit of the diesel engine. Right. So, today we are going to see about the knock, the abnormal combustions in the CI engines. Right. So, before entering this class, just we can recap what are the terms we discussed in last class. So, last class we discussed about the combustion. Right. What is the combustion? Right. Um, in CI engines, only the air is sucking during the suction period, right? The only the air is sucked in the suction stroke, and the fuel is injected at the end of the compression stroke. The fuel is injected at the end of the compression stroke, right? So, um, during the compression stroke, the air is compressed to the high pressure, right? So the pressure ranges, the compression ratio will be 16 to 22, right? So uh, due to the compression of the air, right? So the temperature also increases, right? The temperature of the air inside the cylinder is around 440 to 540 degrees Celsius, right? So, which is beyond the self ignition temperature of the diesel fuel, right? So, the temperature range develops will be 440 to 540 degrees Celsius, which is beyond the level of the beyond the self ignition temperature of the diesel fuel, right? So, that the temperature you have to remember, right? The temperature you have to remember, right? So, the temperature is here 440 to 540 degrees Celsius, right? It is the temperature of the self ignition temperature of the diesel fuel at the compression ratio of 16 to 22, right? Then the fuel is supplied, the fuel is injected through the injector at high pressure, it will be delivered, right? So the pressure will be 100 to 200 bar, right? So it will be supplied, it will be injected through the injector is 100 to 200 pressure bar, right? So then it will be atomized the fuel vapor and mixed with the air, and the combustion will be taking place, the combustion will be starts, right? So it is the very introduction about the combustion of the CI engine. Then in the combustion of the CA engine, we have stages, right? So for the SA engine, we have three stages, but here we have four stages, right? The first stage will be the ignition delay period, right? In the ignition delay period, we have two delays. One is the physical delay and the chemical delay. And for the second stage, the uncontrolled combustion, the period of the uncontrolled combustion, and third stage the controlled combustion, and for the fourth stage burning after burning, right? So then what is the ignition delay? That's the first stage, right? So when the fuel leaves from the nozzle, right, when the fuel leaves from the nozzle, right, that fuel has to take ignite, that fuel has to take ignite, right? So the time delay period from the fuel will be supplied through the injector, right? It leaves from the nozzle, and when it will be uh, when the flame will be propagates, right? So that time period is called the ignition delay period. The time period is called the ignition delay period, right? So in this ignition delay period we have two types of delay. One is the physical delay and one more is the chemical delay, right? So what is the physical delay? That also a time interval, right? That time interval between the fuel leaves from the nozzle, and it will attains its self ignition temperature, it will attains its self ignition temperature, right? So that time period is called the physical delay, right? That time period is called the physical delay, right? So once the physical delay is over, the fuel has to auto ignite. The fuel has to auto ignite and the flame has to appear. The flame has to appear, right? So that time period is called the chemical delay, right? So it's a very important 2 mark question. Just remember, right? So what is physical delay and what is chemical delay? These two delay is called the ignition delay period, right? So start off the injection and start off the ignition. That two terms we have to remember, right? Start off the injection, right? From the nozzle, right? So from the nozzle, right? So from the nozzle, the fuel has to inject, right? So that from the nozzle to the fuel has to burn, right? The time period is called the ignition delay period. In the ignition delay period has to divide into two terms. One is the physical delay and the chemical delay. What is the physical delay? Once the fuel will be comes out from the nozzle and it will attains the self ignition temperature, and it will attains the self ignition temperature, right? So that time period is called physical delay. That time period is called physical delay, right? So once it will attains the self ignition temperature, what will happen? It will auto ignites, right? It will get auto ignition, right? So after once the physical delay is over, right, the chemical delay will occurs, right? So the chemical delay means the fuel has to auto ignite and the flame has to appear. The flame has to appear, right? So that time period is called the chemical delay, right? So it's a important 2 mark question. Just you may remember this one, right? So what is ignition delay period and what is physical delay and what is chemical delay and what is chemical delay, right? So here in this graph you can see here the A point, right? So here the fuel gets starts from the nozzle, right? So that is the start of the injection, right? So A is the start of the injection. The fuel injection will be starts at A point, right? Starts at A point, right? So what will happen means um, the fuel, right? So the fuel will be uh, sprayed through the injection nozzle, right? So during the vaporization process of the fuel, right? So it receives the latent heat. It receives the latent heat from the surrounding of the air, from the surrounding of the compressed air, right? So this will create a slight drop in the pressure. It will create a slight drop in a pressure in the cylinder, right? So that will be represented by the curve AB. That will be represented by the curve AB, right? So due to the vaporization process, what will happen? The latent heat, right, is it will absorbs, the fuel will absorb the latent heat which is surrounding in a compressed air, which is surrounding in a compressed air in a cylinder, right? So due to that, what will happen? The pressure it will be slightly reduces. Initially, it will be slightly drops its pressure, right? So that will be denoted as A B curve. That will be denoted as A B curve. Here you can see the pressure at the point A and pressure at the point B, right? It will have some slight difference, right? Slight pressure drop will be there, right? Is it clear? So first one, so the A B curve, right? Then again we have a C curve also, right? So what will happen? So once the physical delay, right? So during the physical delay, what will happen? The pressure will be slightly reduces, right? So after that, what will happen? Once the physical delay is over, right? So the fuel, the diesel fuel has to auto ignite and the flame has to appear, right? So therefore, the pre-flame reaction starts slowly accelerates until it will get ignition, right? So what will happen? The pre-flame reaction will be occurs, right? The pre-flame reaction will be occurs slowly, right? Then it will be accelerates until it will be ignite the fuel, until it will be ignite the fuel. On that time, what will happen? It will gradually increases its pressure, right? So once the flame will starts to ignite, right? Once the flame will be starts to ignite, that is the flame will be appears, right? So that point will be denoted as C, right? That point will be denoted as C point, right? So whether you can understand this point, these 3 points in this graph, right? So A point is the fuel injection starting point, right? So due to the physical delay, due to the vaporization process, what will happen? The latent heat will be received. The latent heat will be received from the surrounding air inside the cylinder, surrounding air inside the cylinder. On the time, what will happen? It will slightly drop its pressure. That point will be denoted as B, right? So once the physical delay is over, what will happen? The fuel will get the self ignition temperature. The fuel will get the self ignition temperature. After that, the auto ignition will be taking place, right? So once the auto ignition taking place, the flame has to appear, right? So where the flame will be gets to appear, that point is called C point, right? So in this graph you can see these 3 points, right? Is it clear? So A, B, C, right? So this term will be in the first stage, right? This term will be in the first stage, right? So it's a very important 8 mark question or part B question. That's why I'm repeating this one, right? Then the second stage, is a period of uncontrolled combustion. Period of the uncontrolled combustion, right? So once the first stage is over, that is the delay period is over, right? So what will happen? The flame will be appears. The flame will be appears, right? So in that engine, right? In the diesel engine, you may see, for example, it is the engine, right? So it is the engine cylinder, right? So in the cylinder we have plenty of particles, that is air and the fuel. The air and fuel mixture will be there, right? So due to the first stage, right? So for the chemical delay, what will happen means we have one or more flame appearance, right? So we have more flame appearance, right? So in that flame appearance, what will happen? The flame has to propagate in its own flame appearance, right? So here the flame will be appearance, here the flame will be propagates, and here the flame will be propagates, and here the flame will be propagates, right? So there are see, here some flame will be propagates, here some flame will be propagates, here some flame will be propagates. So we have plenty of flame propagation will be there. So the combustion will be the abnormal one, right? The combustion will be uncontrolled one, right? So this time period is called the uncontrolled combustion. This time period is called the uncontrolled combustion, right? So during this uncombustible, that is uncontrollable combustion, the pressure will be gradually increases. The pressure will be rises. The pressure will be, see, the pressure will be rises from the point C to D, from the point C to D, right? So that stage is called the second stage, uncontrolled combustion, right? Uncontrolled combustion, right? So once the uncontrolled combustion will be over, right, then the third one, the controlled combustion will be occurs, right? How we can occurs means, once the all the, see here in this diagram, right? So all the flames will be propagates, right? So all the fuel will be burned, right? All the fuel will be burned, right? So after that, what will happen means the fuel injector sprays the fuel, right? So while spraying the fuel itself, it will be burns, right? While the fuel will be sprays from the nozzle itself, it will be burns, right? So that period is called the controlled combustion. That period is called controlled combustion. There also we have increased some pressure and the temperature. There also we have increased the pressure and temperature, right? So that will be denoted as D and E, D and E. Then after that, what will happen? The fourth stage. After that, the fourth stage, what will happen? The expansion stroke, the power stroke, right? During the power stroke, what will happen? The piston will be moved from TDC to BDC, expansion stroke, right? So the piston will move from TDC to BDC. On the time, what will happen? So the exhaust and the high due to the combustion, it will create a high pressure and the temperature. So that work has to converted, right? That work has to converted into a power stroke. So the piston, the combustion chamber volume will be increases, right? So once increases its volume, right? So on the time, what will happen? The pressure will be gradually reduces. The pressure will be gradually reduces, right? So during the expansion stroke, also we have some flame propagation, right? We have some burning of the fuel. That term is called the after burning. That term is called the after burning. So the curve will be like this, right? So this is called as the fired cycle, right? So the power stroke is called the fired cycle, right? So during the expansion stroke, what will happen? The remaining, we have some after burning, it will be there, right, in the expansion stroke, right? So that is the point F, right? So these are all the stages, right? These are all the combustion stages which is present in a CI engine, right? That is the compression ignition engine, right? So this you have to remember, right? These four stages, right? So it is a 8 mark question or a part B question, right? So combustion stages in the CI engine. Then we have some variables, right? We have some variables, right? What are the effect of the engine variables on the delay period, right? So most of these variables, right? Most of these variables will reduces the delay period, right? So for the compression ratio, if the compression ratio increases, right, the density, pressure and the temperature of the fuel charges, so the increased pressure and the temperature, it will reduces the ignition time delay period, right? So delay period, it will be reduces. And the inlet pressure, right, the inlet pressure increased inlet pressure reduces the time delay period. Why? Because of it will increases the pressure in the combustion stroke. It will increase the pressure in the compression stroke. So the delay time period will be get reduced, right? Then the intake temperature, right? Higher intake temperature will results a high temperatures at the time of the fuel injection. So therefore the delay period will be get reduces, right? So then the engine speeds, right? So increased engine speed will increases the delay period in the terms of the crank rotation, degree of the crank rotation, right? Then the water temperature, jacket water temperature, right? So increased jacket water temperature increases the air temperature, and it will reduces the delay period, right? Then the load, right? So the increased load on the engine reduces the delay period. So the air fuel ratio decreases with the increase the operating temperature, right? Then the injection pressure, then the fuels, injection timing, and the engine size, right? So these here the engine size will not affect, right? Here the engine size has not effect on the delay time period, right? But however, the large engines, right, the large size of the engines operate at the lesser speed, therefore the delay period in the terms of the crank angle is smaller, right? So the less fuel enters into the cylinder and the engine will run smoothly, right? So these terms will affect the delay period, right? So these are the effects on the engine variables on the delay period, right? Then the knocking, right? So what is knocking, right? So the abnormal combustion is called the knocking, right? So in the CI engines, we have abnormal combustion when it will be occurs means due to the delay period, right? So if the delay period increases, what will happen? If the delay period is, what is the delay period? First of all, you have to know what is the delay period. Anyone? Anyone? Kumaravel, what is delay period? Or what is the ignition delay period? Kumaravel, are you there? Kumaravel? Nishant?
Sir.
Nishant, what is ignition delay period?
Sir, இது fuel ignition delay ஆகிறதுக்கு லேட் ஆகும் சார். அது ஃபியூலோட டெம்பரேச்சர் ப்ரெஷர் எல்லாம் இதுவாக இருக்கும் சார்.
I already told that we have delay period. Two types of delay will be there. One is the physical delay and one more is the chemical delay.
Chemical delay.
What is the physical delay?
சார் ஃபிசிக்கல் டிலேனா வந்து அதாவது இக்னிஷன் ஆகிறதுக்கு முன்னாடி இருக்கிற ப்ரெஷர் டெம்பரேச்சர் இருக்கும் சார். அதில் மேக்ஸிமம்
ப்ரெஷர் டெம்பரேச்சர் சொல்லக்கூடாது, ரைட்டா? ஸோ ஃபியூவல் ஓகே, மியூட் பண்ணிக்கோ, எல்லாரும் சொல்லலாம், ரைட்? So once again I'm telling you what is the ignition delay, right? So இந்த நாசில்ல இருந்து ஃபியூவல் வெளியே வருது இல்லையா, இன்ஜெக்டர்ல இருந்து ஃபியூவல் வந்து வெளியே வரும், ரைட்டா? அந்த வெளியே வரக்கூடிய ஃபியூவல் எப்போ நமக்கு வந்து பேர்ன் ஆகி, அதாவது பேர்ன்னா என்னது, ஃப்ளேமா மாறுது, கரெக்டா? அந்த டைம் பீரியட் தான் சொல்லிப்போம் இக்னிஷன் டிலே பீரியட். அதுல ரெண்டு டேர்ம் இருக்கு, ஒன்னு வந்து பிசிக்கல் டிலே, இன்னொன்னு வந்து கெமிக்கல் டிலே, ரைட்டா? பிசிக்கல் டிலே அப்படின்னா என்னன்னா, இப்போ நாசில்ல இருந்து வெளியே வரக்கூடிய அந்த ஃபியூவல், ரைட்டா? நாசில்ல இருந்து வெளியே வரக்கூடிய அந்த ஃபியூவல் என்ன ஆகும், கொஞ்சம் டெம்பரேச்சரை அப்சர்வ் பண்ணும். எங்க இருக்க டெம்பரேச்சர் அப்சர்வ் பண்ணும் அப்படின்னா, அந்த சிலிண்டர்ல இருக்கக்கூடிய சரௌண்டிங், இந்த கம்ப்ரஷன் ஸ்ட்ரோக் ஆல்ரெடி கம்ப்ரஷன் ஸ்ட்ரோக் முடிஞ்சிருக்கு. இந்த கம்ப்ரஷன் ஸ்ட்ரோக் முடியும் போது நமக்கு என்ன ஆகும், கண்டிப்பா வந்து அந்த ஏர் வந்து சம் ப்ரெஷர் அண்ட் டெம்பரேச்சரோட தான் இருக்கும், ஹை ப்ரெஷர் அண்ட் ஹை டெம்பரேச்சரோட தான் இருக்கும். அப்போ வந்து என்ன பண்ணும், அப்சர்வ் பண்ணும் அந்த ஹீட். அந்த ஹீட் தான் சொல்லிப்போம் லேட்டன் ஹீட்னு சொல்லியிருப்போம். அது வந்து என்ன சொல்லியிருப்போம், லேட்டன் ஹீட் ஃப்ரம் த ஏர், ரைட்டா? கம்ப்ரஸ்ட் ஏர்ல இருந்து என்ன பண்ண இருக்கும், அந்த ஃபியூல் வந்து ஒரு லேட்டன் ஹீட்டை அப்சர்வ் பண்ணும். அந்த லேட்டன் ஹீட்டை அப்சர்வ் பண்றதுனால என்ன ஆகும் அப்படின்னா, அந்த ஃபியூலோட டெம்பரேச்சர் இன்க்ரீஸ் ஆகும், கரெக்டா? அந்த ஃபியூலோட டெம்பரேச்சர் வந்து இன்க்ரீஸ் ஆகும், ரைட்? அந்த இன்க்ரீஸ் ஆகக்கூடிய டெம்பரேச்சர் வந்து ஒரு பர்டிகுலர் டெம்பரேச்சர் அட்டன் பண்ணணும். அதான் என்ன சொல்லியிருப்போம், செல்ஃப் இக்னிஷன் டெம்பரேச்சர், கரெக்டா? அந்த ஃபியூல் வந்து அந்த சரௌண்டிங் ஏர்ல இருக்கக்கூடிய டெம்பரேச்சர் எல்லாம் அந்த ஹீட் வந்து அப்சர்வ் பண்ணி இந்த ஃபியூல் வந்து என்ன பண்ணிருக்கோம், கொஞ்சம் ஹீட் வந்து பூஸ்ட் அப் பண்ணி வச்சிருக்கோம், கரெக்டா? அந்த பூஸ்ட் அப் பண்ணி வைக்கக்கூடிய டெம்பரேச்சர் என்ன சொல்லிப்போம், செல்ஃப் இக்னிஷன் டெம்பரேச்சர் அப்படின்னு சொல்லியிருப்போம், கரெக்டா? இதான் சொல்லிப்போம் பிசிக்கல் டிலே, ரைட்? ஸோ ஒன்ஸ் இந்த பிசிக்கல் டிலே முடிஞ்சிருச்சு அப்படின்னா, இந்த ஃபியூலுக்கு ஆல்ரெடி என்ன ஆயிடுச்சு, எனக்கு கொஞ்சம் ஹீட் ஆயிடுச்சு, ரைட்டா? ஸோ அந்த ஹீட் ஆனது ஒரு பர்டிகுலர் ரேஞ்ச் வரைக்கும் தாண்டிச்சுன்னா என்ன ஆகும், ஃப்ளேம் ஆக ஆரம்பிச்சிடும், பேர்ன் ஆக ஆரம்பிச்சிடும், ரைட்டா? ஸோ ஹீட் அப்சர்வ் பண்ணி வச்சிருக்கு, அதை கொஞ்சம் தாண்டினோடனே நமக்கு என்ன ஆகும், ஃப்ளேம் வந்து அப்பியர் ஆக ஆரம்பிச்சிடும். அதான் இந்த ஃபியூல் வந்து இந்த செல்ஃப் இக்னிஷன் டெம்பரேச்சர் தாண்டிச்சு அப்படின்னா ஆட்டோமேட்டிக்கா அது என்ன ஆகும், இக்னைட் ஆக ஆரம்பிச்சிடும், ஆட்டோ இக்னைட், ரைட்டா? ஒன்ஸ் இது ஆட்டோ இக்னைட் ஆச்சு அப்படின்னா கண்டிப்பா நமக்கு என்ன ஆகும், ஃப்ளேம்ன்றது எனக்கு ப்ரொடியூஸ் ஆகும், ரைட்டா? இந்த கேப் என்ன சொல்லிப்போம், கெமிக்கல் டிலே பீரியட் அப்படின்னு சொல்லிப்போம். இந்த கேப் தான் சொல்லிப்போம் கெமிக்கல் டிலே பீரியட், ரைட்டா? இது 2 மார்க் கொஸ்டின், ஞாபகம் வச்சுக்கோங்க, ரைட்டா? இக்னிஷன் டிலேன்றது ஒரு 2 மார்க் கொஸ்டின், பிசிக்கல் டிலேன்றது ஒரு 2 மார்க் கொஸ்டின், கெமிக்கல் டிலே அப்படின்றது ஒரு 2 மார்க் கொஸ்டின், ரைட்டா? ரைட். ஸோ ஒன்ஸ் இந்த நாக்கிங் எதனால வருது அப்படின்னா, we have to the chemical and physical delay increase ஆக what will happen means the amount of the fuel injected is more gets more, கரெக்டா? ஸோ எனக்கு வந்து ஃபியூல் இன்ஜெக்ஷன்ல இருந்து ஃபியூல் வந்து இக்னேட் ஆனாதான் எனக்கு என்ன ஆகும், அது வந்து பேர்ன் ஆகி எக்ஸாஸ்ட் போக ஆரம்பிக்கும், ரைட்டா? பட் வந்து அப்போ அந்த இக்னேட் ஆகுறது எனக்கு என்ன தள்ளி போயிட்டே இருக்கு, ரைட்டா? ஸோ இக்னிஷன் டிலே பீரியட் இன்க்ரீசஸ், ரைட்டா? ஸோ while increasing the delay in period, so what will happen, the amount of fuel injected it gets more, ரைட்டா? ஸோ ஃபியூல் இன்ஜெக்டட்ன்றது அதிகமா இருக்கும், ரைட்? ஸோ அதிகமான ஃபியூல் இன்ஜெக்டட் என்ன ஆயிருக்கும், அக்குமுலேட் ஆகிட்டே இருக்கும், ரைட்டா? இந்த சிலிண்டர்ல இருந்து அந்த அதிகமா வரக்கூடிய ஃபியூல் இன்ஜெக்ஷன், the amount of fuel injected and it will be accumulated in the cylinder, right? It will be accumulated in the combustion chamber, right? That also increases, right? If the delay period gets increases, right? Right. So due to the delay period increases, what will happen, due to the increasing the delay period, so the amount of fuel which is injected and it will be accumulated, will be increases in the combustion chamber, right? So அதிகமான fuels will be there in the combustion chamber, right? So the fuel will be high, fuel will be more in the combustion chamber, so it will burns, it will burns means what will happen, the high pressure and the high temperature will be generated, the high pressure and the high temperature, high pressure and high temperature will be generated in the combustion chamber due to the large amount of the fuel, due to the large amount of the fuel, right? So அந்த மாதிரியான fuel is, that burning is called the knocking or the detonation, knocking or a detonation of the fuel in the CI engines, in the CI engines, right? So that you have to remember, right? So in simple words, how we can explain means, the accumulation of the high fuel, the accumulation of the amount of fuel will be high in the combustion chamber, right? So that will be ignited, that will be ignited with high pressure and the temperature is called the knocking, is called the knocking, right? So ரொம்ப சிம்பிளான கொஸ்டின், ரொம்ப சிம்பிளான டேர்ம் தான் இது, ரைட்டா? வாட் இஸ் knocking? So in the diesel engines, in the diesel engines, if the delay period gets high, what will happen? The amount of fuel injected is more, then it will be accumulated, right? So that accumulated fuel will gets burning, right? On the time, what will happen? It will generate high pressure and the high temperature in the combustion chamber, right? So that is called the term as a knocking or a detonation, right? Right. Then the high rate of the pressure, the high rate of the pressure rises the pulsating combustion, right? It will create very high noise, right? It will create the heavy noise in the engine, right? Right. Sometimes the diesel engine is called as the knock engine, sometimes the diesel engine is called as the knock engine. ஏன் அப்படி diesel engine knock engine கூட சொல்லலாம், ரைட்டா? ஏன் அப்படின்னா, most of the diesel engine the knocking will be there, right? Most of the diesel engine, the engine knocking will be occurs, right? So at the initial stage itself, the knocking will be occurs in the diesel engine, right? The knocking will be occurs during the initial phase, during the initial phase of the combustion, right? So இது எஸ் என்ஜினோட கம்பேர் பண்ணி சொல்றோம், அப்போ இன்னும் சிம்பிளா தெரியும். எஸ் என்ஜினோட கம்பேர் பண்ணி சொன்னா இன்னும் கொஞ்சம் சிம்பிளாவே உங்களுக்கு தெரியும், ரைட்டா? So it is the abnormal condition, right? So if the fuel will be burns in a normal burning means, so it will be, the curve will be like this, right? So if the fuel will be injected, then the knocking will be occurs, see, the knocking will be occurs, right? In CA engine, the knocking will be occurs during the initial phase of the combustion, during the initial phase of the combustion, right? So here you can see, in the initial phase of the combustion, here the ignition and the injection will be starts, then here the flame will be propagates, right? So after that, what will happen? See, the curve will be the zigzag. So the pressure and the temperature, the pressure and the temperature will be increases, right? The pressure and temperature will be rises in abnormal condition, right? So the zigzag curve will be there, right? So it is the abnormal burning, that is it is the abnormal combustion in the C engine. That abnormal combustion is called the knocking, the abnormal combustion is called knocking, right? So the effects, right? What are the factors affecting the knocking in the combustion chamber means, the same term, right? So what are the terms, right? So these are the terms, these are the variables in the CI engines, right? So first one is the fuel, that is for generally the diesel fuel will be indicated as the cetane number, right? So if the cetane number increases, then it will be good, right? So high cetane engine, high cetane fuels will be good, right? It will reduces the knocking, right? So the cetane number, it will be decreases the knocking tendency, right? It will be decreasing the knocking tendency. And the temperature of the inlet air, the inlet fuel, and the water, right? Jacket water temperature, right? So it will decreases the knocking tendency, right? Then the intake pressure will decreases and the load will be decreases, injection pressure will be decreases. And here you can see the engine, the ignition advance angle, right? So what is the advance angle means, for the valve timing and port timing diagram, right? So where the injection will be taking starts, right? So that it will be somewhat if the injection taking will be in advanced angle, right? So there the engine tendency will be increases, right? So there the injection why? Because if the injection advance angle will be there, means the ignition delay period will gets more, right? The ignition delay period will gets more, right? So on the time it will increases the engine knock tendency, right? It will increases the engine knock tendency. Then the higher speed, right? So the speed also increases the knock tendency, right? So the remaining term, the compression ratio, engine size, and the injection pressure load, and the intake pressure, and the intake temperature, air temperature, fuel temperature, that and all decreases the engine knocking tendency, right? So here you can see the comparison, right? So in the SI engines, when where the knocking will be occurs means at the end of the compression stroke, at the end of the at the end of the combustion stroke, at the end of the combustion stroke, right? Once the compression will be taking place, so the fuel gets into the combustion chamber as a air and fuel mixture, then the spark will be produces, right? On the time the flame will be propagates in a uniform manner, right? So if uh, if the flame will be gets auto ignited at the end of the charge, right? So that before reaching its flame, right? So that is called the abnormal combustion in the SI engine, right? But in CI engine you can see the abnormal combustion will be starts at initial stage itself, right? So here the initial stage itself the abnormal combustion will be taking place, but in SI engines at the end of the stroke the abnormal combustion will be taking place, right? Here the initially in from the initial itself the abnormal combustion will be taking place, right? So you can differ this graph itself from the SI engine and the C engine, the comparison you can see, right? So the knocking, where the knocking will be occurs, right? So in the SI engines, in the SI engine the knocking is due to the N charge, right? Due to the N charge auto ignition, right? Then in CI engines the the knocking will be taking place due to the self ignition temperature, that is the auto ignition of the flame, right? The auto ignition of the flame which is presented in the combustion chamber will be somewhat high due to the lag period, right? Due to the lag period, so the abnormal combustion will be taking place at the initial stage itself, right? Then in SI engines, right? In the SI engine, the pressure rises is very high due to the knocking period. Due to the knocking, why? Because it is a homogeneous mixture, right? It is a homogeneous mixture, right? But in CI engines, it's not that. Here it is the heterogeneous mixture, right? Then the changes in the pre-ignition will be occurs in SI engine, but in the CI engine it will not there, right? Why? Because the fuel will be injected at the end of the compression stroke, right? But the in SI engines we are supplying the air fuel mixture into the cylinder during the suction stroke, so the pre-ignition may be a chances, right? A pre-ignition may be chances in the SI engine, but it is not possible in the C engine. Why? Because we have to supply the fuel through the injector at the end of the compression stroke, right? So here the pre-ignition will not be there in the compression ignition engine, right? It will be only a chance for the SI engines, right? Then in the CI engine, the knocking will be increases due to the ignition delay period time increases, right? But we can minimize the delay period, but we can't control. We can't be a zero, right? We can't uh, to be the zero for the initial ignition delay period, right? So always, always we have some pressure rise due to the accumulation of the fuels, right? Accumulation of the fuel. So surely knocking will be there in the CI engines. Surely the knocking will be there in the CI engine. So the CI engine is also called as the knock engine. The CI engine is also called as the knock engine, right? So this term you have to remember, right? This term you have to remember, right? Then what are the factor tendencies to reduce the knocking, right? To reduce the knocking in SI engines and the C engine, the comparisons, right? So for the compression ratio for the S engine, it will be low, and here it will be high. Then the inlet temperature for the S engine low and C engines are high, and for the inlet pressure and for the self ignition temperature, right? Then the delay period, the load of the engine, then the combustion valve temperature, engine speed, and the engine size, right? So these are the factors, right? These are the factors we have to compare, right? So for the S engines and the C engines, right, that will be displayed here. Just you can see, right? So for the inlet pressure, for the S engine is low and C engine is high, and for the self ignition temperature of fuel, right? So for the SI engine it will be high, and for the diesel engine it will be a low. Then the time delay period, which is longer in SI engine, and the C engine, which is a shorter one, and the load of the engine for the petrol and for the gasoline engine it will be low, that is SI engine will be low, and for the CI engine it will be high. Then the combustion valve temperature, right, obviously high in the CI engines, and the load and the speed performance will be low in the diesel engines, and the size, the cylinder size will be, engine size will be high in the larger in the CI engines, right? Then the combustion chamber design for the CI engine and the SI engine will be see in the next class, right? So that will be see in the next class, right? Then do you have any doubt in this class? Do you have any doubt in this class? Just reply. So in this class we have seen what is the combustion and what is the combustion stages, and what is knock, and what are the factors, right? What are the factors which affects the knocking tendency, right? So that time we discussed in this class. Do you have any doubt in this class?
No, sir.
No, right? Then you can leave the class and join the other class at 9:30 sharp. Thank you.